The morning air in Dearborn, Michigan carried an unusual electricity on May 26, 1940, as President Franklin Delano Roosevelt's voice crackled through radio speakers across America. His fireside chat would change everything. "We must harness the efficient machinery of America's manufacturers to produce 50,000 combat aircraft over the next 12 months. Roosevelt declared, his words sending shockwaves through corporate boardrooms and factory floors alike. In his River Rouge office, Henry Ford I leaned back in his leather chair, his weathered hands folded as he absorbed the magnitude of Roosevelt's challenge. The 77-year-old industrialist had revolutionized automobile manufacturing with his assembly line concept, but aircraft? That was an entirely different beast. Each bomber contained over 1.5 million individual parts, requiring precision that made automobile manufacturing look like child's play. Charles Emil Sorensen, Ford's right-hand man and the architect of the Rouge plant's success, burst into Ford's office with blueprints already unfurling from his arms. "Mr. Ford," Sorensen announced with characteristic boldness, "I can build you a factory that will produce one bomber every hour." The room fell silent. Even Ford, accustomed to audacious statements, raised an eyebrow at his lieutenant's proclamation. The Consolidated Aircraft Corporation's B-24 Liberator bomber was a mechanical marvel weighing 65,000 pounds when fully loaded. Its 4 Pratt & Whitney engines generated enough power to carry 10 men and their equipment across vast ocean distances to rain destruction upon enemy targets. Traditional aircraft manufacturing involved skilled craftsmen hand-fitting each component, a process that took weeks for a single aircraft. Sorensen's vision was radical. Apply Ford's revolutionary assembly line principles to aircraft manufacturing. Instead of workers moving to the aircraft would move to the workers. Each station would perform specific tasks with machine-like precision and timing. "We'll break down every process into its simplest components," Sorensen explained, his eyes blazing with the fervor of an industrial evangelist. "Time and motion studies will eliminate every wasted second." The government officials who arrived from Washington the following week carried skepticism like briefcases. How could an automobile manufacturer, they wondered, master the intricate art of aircraft production? Traditional aircraft plants employed highly skilled craftsmen who spent years learning their trade. Ford proposed replacing artisans with assembly line workers who could be trained in weeks. Construction began immediately on what would become the largest manufacturing facility under one roof in the world. The Willow Run plant, designed by architect Albert Kahn, would stretch over 3.5 million square feet. The main assembly line alone measured 1 mile in length, earning the nickname the Mile-Long Building. Workers joked they needed bicycles to navigate the sprawling complex. The challenges seemed insurmountable from the beginning. Aircraft manufacturing demanded tolerances measured in thousandths of inches, far more precise than automobile production. The B-24's wingspans stretched 110 feet, requiring specialized fixtures and handling equipment that had never been conceived. Traditional riveting techniques, adequate for cars, proved inadequate for aircraft that would face combat conditions at 25,000 feet altitude. Ford's purchasing department faced its own logistical nightmare. The Liberator required materials from hundreds of suppliers scattered across the continent, aluminum sheets from Alcoa plants in Pennsylvania, engines from Pratt & Whitney in Connecticut, and specialized instruments from dozens of smaller manufacturers. Coordinating delivery schedules to maintain steady production flow would require unprecedented precision. Labor recruitment presented another monumental challenge. Ford needed to hire and train over 40,000 workers, many of whom had never set foot in a factory. The workforce would include housewives, farmers, and immigrants, all requiring education in complex manufacturing processes. Training programs operated around the clock, with instructors teaching everything from basic tool usage to quality control procedures. The very foundation of American industrial might was being tested in ways it had never been challenged before. 3,000 miles across the Atlantic, in the heart of Berlin's government district, a different kind of factory hummed with deadly efficiency. The Abwehr, Germany's military intelligence organization, operated from an unremarkable building on Tirpitzhofer, where maps of American industrial sites covered entire walls like pieces of a vast puzzle. Colonel Wilhelm Franz Canaris, the Abwehr's enigmatic chief, studied aerial reconnaissance photographs of the Willow Run construction site with growing concern. "Mein Gott," whispered Hauptmann Klaus Weber, an intelligence analyst specializing in American industrial capacity. Weber had spent years studying Ford's manufacturing methods, initially dismissing them as crude American mass production techniques. Now, watching bulldozers reshape the Michigan landscape into what appeared to be the world's largest factory, he felt the first stirrings of genuine alarm. The German High Command had initially scoffed at Roosevelt's 50,000 aircraft pledge, viewing it as typical American bluster designed to boost home front morale. Their calculations, based on traditional European aircraft manufacturing methods, suggested such production levels were mathematically impossible. Each Heinkel He-111 bomber required approximately 6 months to complete using Germany's most efficient production methods. Even if Americans somehow doubled that efficiency, they could never achieve the astronomical production rates Roosevelt had promised. Lieutenant Walter Kappe, attached to Abwehr II Intelligence Division, had spent considerable time in the United States before the war. His experience with the German-American Bund had provided intimate knowledge of American industrial capabilities. "The Americans possess manufacturing infrastructure we cannot match," Kappe reported to his superiors, his warnings often falling on deaf ears. "Their automobile factories represent mass production on scales we have never attempted." Edmund Karl Heine presented the Reich's most valuable intelligence asset inside Ford Motor Company. A German native who had immigrated to America in 1914, Heine had worked his way up through Ford's foreign sales and service departments. His legitimate business activities provided perfect cover for intelligence-gathering operations. Until 1938, he held various positions in the foreign sales and service department of Ford Motor Company and Chrysler Motor Corporation. Heine's reports painted an increasingly disturbing picture of American industrial mobilization. Ford's Rouge River complex already demonstrated production capabilities that German intelligence analysts had deemed impossible. The planned Willow Run facility threatened to dwarf even those achievements. Heine's carefully coded messages, transmitted through seemingly innocent business correspondence, carried details that kept German intelligence officers awake at night. The Duquesne spy ring, operating under Frederick Joubert Duquesne's leadership, represented Germany's most comprehensive intelligence network on American soil. 33 agents embedded throughout American industrial centers gathered information on everything from ship construction to aircraft manufacturing. Their reports, when compiled, revealed the staggering scope of American industrial mobilization. German military planners had based their war strategy on limiting American industrial output through submarine warfare. If American factories could not receive raw materials or ship finished products, their productive capacity became irrelevant. The Battle of the Atlantic represented Germany's effort to strangle American industry in its cradle. Every Liberty ship sunk, every convoy scattered, served this strategic objective. Intelligence photographs of the Willow Run construction site revealed troubling details. The facility's single assembly line stretched farther than most German aircraft factories' entire footprint. Specialized railroad connections would bring raw materials directly into the plant, while finished aircraft would taxi onto adjacent runways. The integration of transportation, manufacturing, and delivery systems represented industrial planning on previously unimaginable scales. Weber's analysis team worked frantically to understand Ford's production methodology. German factories still relied heavily on skilled craftsmen whose knowledge passed from master to apprentice over years of training. Ford's system threatened to replace craftsmanship with mechanized precision, potentially producing aircraft faster than Germany could destroy them. The implications were staggering. America might achieve air superiority through sheer numerical advantage rather than technical superiority. Colonel Canaris himself reviewed the Willow Run intelligence files, recognizing their strategic significance. If Ford's boasts proved accurate, the Luftwaffe would face an enemy capable of replacing aircraft losses faster than German pilots could shoot them down. The mathematics of aerial warfare would fundamentally change. Germany's carefully trained pilots, representing years of investment, would face an endless stream of American aircraft and hastily trained crews. Winter snow covered the Willow Run construction site like a white shroud as 1941 dawned with ominous uncertainty. Pearl Harbor's December 7th attack had transformed America's industrial mobilization from ambitious peacetime planning into desperate wartime necessity. The sprawling factory complex, still under construction, suddenly became a symbol of American determination to answer aggression with overwhelming productive force. Charles Sorensen stood at the facility's center, surveying the organized chaos surrounding him. Thousands of workers swarmed the site like ants building their hill, each carrying specific purposes in the grand design. The main assembly building now stretched its full mile length, its steel skeleton reaching toward gray Michigan skies. Inside, workers installed the specialized machinery that would transform raw materials into flying weapons. The B-24 Liberator production line represented engineering marvel that challenged conventional manufacturing wisdom. Traditional aircraft assembly required skilled workers to bring tools and parts to stationary airframes. Sorensen's revolution moved the aircraft itself along a continuously flowing line while workers remained at fixed stations. Each worker would learn specific tasks rather than comprehensive aircraft construction, dramatically reducing training time. Training programs operated 24 hours daily as Ford struggled to educate its rapidly expanding workforce. Rosie the Riveter became more than wartime propaganda. She represented thousands of women entering industrial employment for the first time. Former housewives learned to operate rivet guns, install wiring harnesses, and perform quality control inspections. Their dedication compensated for their inexperience through sheer determination. The complexity of coordinating 1,500 individual suppliers boggled even experienced purchasing agents. Each B-24 required components manufactured across the entire continent. Aluminum sheets from Pennsylvania, engines from Connecticut, instruments from California. A delay at any supplier could halt the entire production line, making logistics coordination as critical as manufacturing itself. Quality control presented unprecedented challenges as Ford adapted automobile standards to aircraft requirements. Cars that leaked oil or squeaked might annoy customers. Aircraft with similar defects killed crews. Every rivet, every wire connection, every fuel line required inspection standards that exceeded automotive manufacturing by orders of magnitude. Rejection rates initially reached catastrophic levels as workers learned the difference between good enough and flight-worthy. Lieutenant Colonel Orville Anderson, representing the Army Air Forces, established residence at Willow Run to monitor Ford's progress. His reports to Washington mixed admiration with growing impatience as production targets slipped month after month. The military needed bombers immediately, while Ford struggled with manufacturing processes that proved far more complex than Sorensen's original estimates. Aircraft engines posed particular problems for Ford's mass production approach. The Pratt & Whitney R1830 twin Wasp engines required precise calibration and testing that resisted assembly line techniques. Each engine represented a complex mechanical symphony where timing, fuel mixture, and cooling systems required individual attention. Ford's attempts to standardize engine installation created bottlenecks that rippled throughout the entire production process. The plant's sheer scale created unexpected problems. Workers needed 15 minutes just to walk from the parking lot to their stations. The mile-long assembly line meant that quality control inspectors required transportation to reach problem areas quickly. Communication systems designed for automobile plants proved inadequate for coordinating activities across such vast spaces. Material handling systems designed for automobile components struggled with aircraft parts' size and weight. Wing panels measured over 50 feet in length while fuselage sections weighed thousands of pounds. Specialized cranes, conveyor systems, and handling fixtures required constant modification as engineers learned through trial and error. Every day brought new challenges that demanded innovative solutions. By late 1941, Willow Run had achieved initial production milestones, rolling out its first complete B-24 in September. The aircraft, designated Ford 1, represented triumph over skeptics who had declared mass aircraft production impossible. However, the single aircraft had required months to complete, falling far short of Sorensen's 1 bomber per hour promise. The learning curve proved steeper than anyone anticipated. Traditional aircraft manufacturers employed craftsmen with decades of experience, while Ford relied on workers with weeks of training. Initial aircraft required extensive rework, as quality control inspectors identified problems ranging from improperly installed instruments to structural defects. Each problem forced production line modifications and additional worker training. The gray December morning of 1941 carried more than winter's chill through the streets of New York City. Federal Bureau of Investigation agents moved with purposeful precision as they executed simultaneous arrests across the metropolitan area. Operation Duquesne spy ring's culmination had arrived, netting 33 German agents in the largest espionage bust in American history. Edmund Karl Heine found himself in FBI custody as agents searched his modest apartment near Ford's Manhattan sales office. Years of carefully gathered intelligence on American industrial capacity lay scattered across his desk like fallen leaves. Photographs of the Willow Run facility, production schedules, and detailed reports on Ford's manufacturing capabilities provided federal investigators with disturbing evidence of German intelligence penetration. Special Agent Thomas Joseph Donegan examined Heine's files with growing amazement. The German spy network had achieved remarkable intelligence-gathering success, documenting American industrial mobilization with precision that impressed even FBI analysts. Coded messages revealed German knowledge of production targets, manufacturing methods, and strategic planning that supposedly remained classified. The breadth of their intelligence operations shocked American counterintelligence officers. Back in Berlin, Colonel Canaris received news of the spy ring's destruction with characteristic stoicism. The Abwehr had lost its most valuable intelligence network just when accurate information about American production capabilities became most critical. Remaining intelligence sources provided fragmentary reports that painted an increasingly alarming picture of Ford's progress at Willow Run. Hauptmann Weber's analysis team worked desperately to interpret scattered intelligence reports filtering through neutral countries. Swiss business travelers, Swedish journalists, and Argentine trade representatives provided glimpses of American industrial activity. Each report suggested that Ford's bomber production was accelerating beyond German calculations, threatening the Reich's strategic assumptions about prolonged warfare. German military planning had assumed that America's industrial soft power would require years to convert to military production. European experience suggested that democratic nations lacked the authoritarian control necessary for rapid industrial mobilization. Hitler's advisors repeatedly assured him that American consumer culture would resist the sacrifices required for total war production. Intelligence photographs obtained through neutral diplomatic sources revealed disturbing changes at Willow Run throughout early 1942. The facility's parking lots expanded weekly as Ford's workforce grew toward its eventual 40,000-person peak. Railroad sidings multiplied like arteries feeding the industrial heart, while aircraft on the adjacent airfield suggested accelerating production rates. Weber's team attempted to calculate American aircraft production using traditional European manufacturing standards. Their mathematics suggested that Ford's claimed production rates violated physical laws of assembly complexity. Aircraft construction required thousands of individual operations, each demanding specific skills and time allocations. Mass production techniques might reduce assembly time, but could never achieve the rates Ford publicized. The German High Command's intelligence briefings throughout 1942 reflected growing confusion about American capabilities. Reconnaissance flights over British airfields showed increasing numbers of American-built aircraft, suggesting that Ford's production claims contained disturbing elements of truth. Luftwaffe pilots reported encountering B-24 formations that seemed to multiply faster than German industrial intelligence predicted possible. Colonel Adolf Galland, Germany's ace fighter pilot and tactical expert, provided sobering assessments of American aircraft encounters. The Americans appear to possess unlimited aircraft reserves, Galland reported, after examining combat loss statistics. Every squadron we destroy is replaced within weeks. Their production rates suggest manufacturing capabilities we have never encountered. By spring 1942, scattered intelligence reports confirmed that Ford had achieved sustained B-24 production, though exact rates remained unclear. German agents in neutral Switzerland reported American boasts about one bomber every hour, claims that German analysts dismissed as propaganda until supporting evidence began accumulating from multiple sources. The Reich's strategic planning assumed that German technical superiority would compensate for American numerical advantages. Luftwaffe aircraft featured advanced engineering and experienced pilots, while American aircraft reportedly relied on mass production techniques that sacrificed quality for quantity. This assumption provided comfort until combat reports suggested that American quantity was overwhelming German quality through sheer numerical superiority. Intelligence summaries reaching German military commanders painted increasingly desperate pictures of Allied bombing campaigns. British Royal Air Force night raids combined with American daylight bombing to create around-the-clock pressure on German industrial targets. The sustained bombing campaigns required aircraft replacement rates that traditional manufacturing could never support, yet American formations maintained strength levels that defied German understanding. Spring 1943 brought revolutionary changes to the Willow Run production line, as Ford's manufacturing engineers finally mastered the complex choreography of mass aircraft production. The morning shift change resembled a small city awakening. 42,000 workers streaming through factory gates represented more people than lived in most American towns. Their collective mission was transforming raw materials into flying fortresses at rates that defied traditional manufacturing logic. Charles Sorensen surveyed his industrial kingdom with satisfaction, tinged by exhaustion. The past 2 years had tested every principle of mass production he had spent decades perfecting. Aircraft manufacturing demanded precision tolerances that made automobile production seem crude by comparison. Each B-24 required over 36,000 rivets installed with mathematical precision. A single misplaced rivet could cause catastrophic structural failure at 25,000 feet altitude. The assembly line's rhythm had evolved into a mechanical symphony where timing meant everything. Every 63 minutes, a completed bomber emerged from the final assembly station, its 4 engines tested and calibrated, its instruments calibrated, its structure inspected by quality control teams whose standards would have impressed Swiss watchmakers. That April, employees in 2 9-hour shifts, working 6 days a week, produced 453 airplanes in 468 hours, a production rate equal to one finished B-24 Liberator every 63 minutes. The workforce diversity represented a social revolution, as dramatic as the manufacturing breakthrough. Women comprised over 40% of Willow Run's employees, performing jobs previously reserved for men. African Americans from the South joined European immigrants in an industrial democracy where skills mattered more than background. The plant's cafeterias served meals in multiple languages, while training programs operated with translators to accommodate the international workforce. Each bomber rolling off the production line contained 1,500,000 individual parts, sourced from over 1,500 suppliers scattered across North America. The logistics coordination required to maintain steady production flow challenged every principle of supply chain management. Raw aluminum arrived by railroad from Pennsylvania, while engines shipped from Connecticut plants that operated their own complex supply networks. Quality Control Inspector Margaret Wilson exemplified the dedication driving Willow Run's success. A former school teacher from rural Michigan, Wilson had trained for 6 months to master aircraft structural inspection techniques. Her keen eye had identified hundreds of potentially dangerous defects, each representing American air crews whose lives depended on manufacturing precision. "Every rivet I approve," Wilson often told trainees, "carries 10 men into combat." The plant's scale continued to amaze even experienced manufacturing engineers. The main assembly building's mile-long length required internal transportation systems resembling a small city's infrastructure. Workers used bicycles, electric carts, and pneumatic tube systems to navigate the complex. The facility consumed as much electricity as Detroit, while requiring its own fire department, medical clinic, and security force. Material flow through the production line resembled a mechanical river, where aluminum sheets entered at one end and emerged as flying aircraft at the other. Specialized machinery shaped wing panels with precision measured in thousandths of inches, while hydraulic presses formed fuselage sections that would withstand combat stresses. Each manufacturing station represented engineering solutions to problems that had never existed before mass aircraft production. Training programs evolved into sophisticated educational systems that transformed inexperienced workers into skilled technicians within weeks. Veterans of the automobile industry adapted their skills to aircraft requirements, while newcomers learned specialized techniques through hands-on experience. The plant operated its own technical school where instructors taught everything from blueprint reading to advanced metallurgy. Production statistics compiled by Ford's accounting department documented achievements that seemed impossible even to participants. In April 1943, Willow Run produced 453 complete B-24 bombers, exceeding the combined monthly output of all other American aircraft manufacturers. Each aircraft represented approximately 45,000 hours of labor, coordinated across hundreds of specialized operations. The economic impact extended far beyond aircraft production, as Willow Run's success demonstrated American industrial capacity to skeptical allies and enemies alike. British officials, initially doubtful about American manufacturing capabilities, sent teams of observers to study Ford's methods. Soviet representatives, despite political tensions, recognized the strategic implications of mass aircraft production for the broader war effort. Local communities surrounding Willow Run experienced unprecedented prosperity as Ford's payroll pumped millions of dollars into the regional economy. Housing development sprouted around the plant to accommodate the massive workforce, while local businesses expanded to serve the industrial boom. The transformation resembled the California gold rush as people flocked to participate in the manufacturing miracle. The autumn of 1943 arrived in Berlin with news that shattered German strategic assumptions about American industrial capacity. Intelligence reports, compiled from scattered sources across neutral Europe, painted a terrifying picture of Ford's Willow Run production achievements. The facility was not merely producing aircraft at unprecedented rates, it was redefining the very mathematics of modern warfare. Hauptmann Klaus Weber stared at the intelligence summary that would change everything German military planners thought they knew about industrial warfare. According to multiple confirmed sources, Ford Motor Company was indeed producing one complete B-24 Liberator every 63 minutes, 24 hours per day, 7 days per week. The mathematical implications were staggering. Over 500 bombers monthly from a single American factory. Reich Minister Albert Speer, Germany's armaments production chief, received Weber's report with characteristic analytical precision. Speer's own industrial expertise allowed him to understand the revolutionary significance of Ford's achievement. "Gentlemen," Speer addressed his staff during an emergency production meeting, "the Americans have solved problems we did not know existed. They are not simply building aircraft, they are manufacturing air superiority." German aircraft production, despite Speer's organizational reforms, struggled to achieve monthly outputs that Ford apparently surpassed weekly. The Messerschmitt factories, operating with Germany's most efficient production methods, required skilled craftsmen working months to complete single aircraft. American mass production techniques threatened to bury the Luftwaffe under numerical superiority that no amount of pilot skill could overcome. Colonel Gallen's combat reports from the Western Front provided disturbing confirmation of intelligence estimates. "Every week brings fresh American bomber formations," Gallen reported to Reichsmarschall Hermann Göring. "We destroy 10 aircraft on Monday, 20 arrive on Tuesday. Our pilots achieve individual victories while losing the broader campaign through mathematical impossibility." The psychological impact on German industrial workers proved as devastating as the strategic implications. News of American production achievements, despite censorship efforts, filtered through the Reich's workforce. German aircraft factory workers, already struggling with material shortages and bombing disruptions, learned that their American counterparts were achieving production rates that seemed to mock German industrial traditions. Operation Point Blank, the combined bomber offensive launched by British and American air forces, demonstrated the strategic implications of Ford's production miracle. Wave after wave of B-24 formations struck German industrial targets with relentless precision. Each aircraft lost in combat was replaced faster than German intelligence analysts had deemed mathematically possible. Luftwaffe strength reports documented the Reich's losing battle against American industrial capacity. German aircraft production peaked at approximately 1,500 fighters and bombers monthly, while facing Allied bombing campaigns that destroyed hundreds of German aircraft weekly. The mathematics of attrition favored the side that could replace losses faster than the enemy could inflict them. Hitler's reaction to intelligence briefings about American production capacity revealed the Führer's fundamental misunderstanding of industrial warfare principles. German quality will that suggested otherwise. His refusal to acknowledge American achievements prevented realistic strategic adjustments that might have conserved German resources for defensive operations. Reich propaganda minister Joseph Goebbels struggled to counter American production claims without acknowledging their accuracy. German media portrayed American aircraft as inferior products of mass production techniques while avoiding specific comparisons with German output rates. The propaganda campaign required careful balance between maintaining home front morale and avoiding claims that combat results would contradict. Scientific analysis of captured American aircraft revealed disturbing evidence of manufacturing sophistication that contradicted German assumptions about mass production quality. American B-24 bombers demonstrated structural integrity, systems reliability, and manufacturing precision that matched or exceeded German standards. The Reich's technical experts reluctantly admitted that American quantity maintained impressive quality. German submarine warfare, originally designed to strangle American industrial output by controlling Atlantic shipping lanes, faced the reality that American production had achieved levels where transportation became secondary to manufacturing capacity. Even successful U-boat campaigns against Allied convoys could not reduce American aircraft output to manageable levels. Intelligence summaries reaching German military commanders throughout late 1943 documented Ford's continuing production acceleration. Willow Run was not merely maintaining its 63-minute production rate. The facility was expanding capacity while other American manufacturers implemented similar mass production techniques. The combined bomber offensive represented only the beginning of American industrial dominance in aerial warfare. By January 1944, Willow Run had evolved beyond a manufacturing facility into a symbol of American industrial supremacy that reverberated across every theater of World War II. The facility's production statistics read like fantasy to European observers. Ford Motor Company was building one airplane every 63 minutes at its Willow Run plant by March 1944. Ford produced its 6,000th B-24 that September. The numbers represented more than manufacturing success. They embodied democracy's capacity to organize, produce, and fight on scales that authoritarian regimes had never imagined possible. Charles Sorensen walked the mile-long assembly line each morning, observing the mechanical ballet that had become second nature to 42,000 workers. The production process resembled a vast organism where each component moved with biological precision. Wing panels flowed from fabrication areas, while fuselage sections merged with landing gear assemblies in choreographed movements that had required years to perfect. Every 63 minutes, another B-24 rolled toward the runway, ready to carry war to the Reich's heartland. The strategic implications transcended mere aircraft production statistics. Allied bomber formations over Europe grew stronger monthly while German fighter squadrons struggled to maintain operational strength. The combined bomber offensive had evolved from strategic concept into industrial reality, supported by American production capacity that could sustain losses indefinitely. German cities experienced around-the-clock bombing campaigns that previous generations of military planners had considered impossible. Soviet representatives, despite political tensions with Western allies, recognized Ford's achievement as strategically decisive for the broader war effort. Colonel Ivan Petrov, a technical observer attached to Soviet purchasing missions, submitted reports to Moscow that emphasized American production methods' potential applications for post-war reconstruction. The Red Army's eventual victory would require industrial reconstruction on scales that only American techniques might accomplish. British Royal Air Force commanders, initially skeptical about American industrial promises, acknowledged that Ford had achieved production miracles that changed aerial warfare fundamentals. Air Chief Marshal Arthur Harris, architect of the area bombing campaign, incorporated American production statistics into strategic planning with confidence that aircraft losses could be sustained indefinitely. The mathematical balance of aerial combat had shifted permanently in the Allies' favor. Japanese intelligence services, monitoring American industrial mobilization through neutral diplomatic channels, provided Tokyo with disturbing assessments of Pacific theater. Implications. If Ford could mass-produce heavy bombers for European operations, similar techniques could support B-29 Superfortress production for Pacific campaigns. Japanese industrial planners recognized that their nation faced American productive capacity beyond anything Asian manufacturing could match. The Willow Run workforce had evolved into a community representing American society's full diversity. Workers from all backgrounds collaborated in common purpose while earning wages that transformed their families' economic prospects. Women riveting wing panels earned salaries that provided independence previously unknown. African Americans from southern agricultural regions discovered industrial opportunities that would reshape their communities for generations. Local Michigan communities experienced prosperity unprecedented in their history as Willow Run's economic impact rippled throughout the regional economy. Housing developments, retail establishments, and service industries expanded to support the massive industrial workforce. The transformation resembled westward expansion's boom town phenomenon, concentrated in a single location dedicated to aircraft production. Ford's supply chain coordination demonstrated American logistical capabilities that impressed military observers worldwide. Raw materials arrived from across the continent with precision that maintained steady production flow despite wartime transportation challenges. The coordination required to synchronize 1,500 suppliers' deliveries with assembly line requirements represented management achievement as significant as the manufacturing breakthrough itself. Quality control standards at Willow Run exceeded those of traditional aircraft manufacturers who had criticized Ford's mass production approach. Statistical analysis of completed aircraft revealed defect rates lower than industry averages, while production speeds far exceeded traditional manufacturing capabilities. American engineering had successfully combined quantity with quality in proportions that European manufacturers had deemed impossible. The psychological impact on German military morale became apparent through prisoner interrogation reports and captured correspondence. Luftwaffe pilots, facing endless streams of American bombers, recognized that individual heroism could not overcome industrial mathematics. German aircraft factory workers, struggling with material shortages and bombing disruptions, understood that their enemies possessed manufacturing advantages that traditional craftsmanship could never match. International observers studying Willow Run's operations recognized that Ford had revolutionized not merely aircraft production, but industrial organization itself. Mass production principles, refined through decades of automobile manufacturing experience, had proven applicable to the most complex mechanical systems. The implications extended beyond wartime applications to post-war economic reconstruction and industrial development worldwide. April 1945 brought spring's renewal to Michigan's countryside surrounding Willow Run. But inside the massive facility, the approaching war's end carried bittersweet implications for the 42,000 workers who had dedicated their lives to bomber production. Ford built 6,972 B-24s in 776 days and produced kits for 1,893 more to be assembled by the other manufacturers. The final statistics documented achievement that had transformed global warfare while proving democratic society's capacity for industrial organization beyond authoritarian comprehension. The last B-24 Liberator rolled off the Willow Run production line on June 28, 1945, its aluminum skin gleaming under factory lights that had burned continuously for 4 years. Serial number 44-51928 represented more than the final aircraft. It symbolized American industrial victory over enemies who had underestimated democracy's organizational capabilities. Charles Sorensen, now 74 years old, watched the ceremony with satisfaction tempered by melancholy for an era ending. German industrial collapse in the war's final months vindicated every intelligence report that had documented American production superiority. Allied bomber formations, supported by fighter escorts produced in similar American factories, had systematically destroyed the Reich's manufacturing capacity while suffering losses that could be replaced within days. The strategic bombing campaign achieved victory through mathematical inevitability rather than individual heroism. Colonel Klaus Weber, now in Allied custody, provided post-war interrogators with detailed assessments of German intelligence failures regarding American industrial capacity. "We understood individual American achievements," Weber explained, "but never comprehended the systematic organization that made such achievements sustainable. Ford did not simply build aircraft. They manufactured victory through industrial precision. The economic transformation of American society through wartime production extended far beyond military applications. Willow Run's workforce had demonstrated that democratic societies could organize complex industrial operations while maintaining individual freedoms that authoritarian regimes sacrificed for temporary efficiency. The women, minorities, and immigrants who had built bombers would reshape post-war America with skills and confidence gained through wartime service. International recognition of American industrial achievement came from unexpected sources as former enemies acknowledged the production miracles that had defeated them. German industrial engineers, interviewed by Allied technical teams, expressed professional admiration for manufacturing methods that had seemed impossible according to European standards. Japanese officials, facing post-war reconstruction, sought American assistance in implementing mass production techniques for peaceful purposes. The strategic implications of Willow Run's success influenced post-war military planning, as American commanders recognized that future conflicts would be decided by industrial capacity rather than traditional military factors. The facility's production records became classified documents studied by defense planners who understood that America's security depended on maintaining the industrial base that had achieved victory. Sorensen's memoirs, published years later, reflected on the human drama behind the production statistics that had amazed the world. "Every aircraft we built carried 10 men into combat," Sorensen wrote. "Every rivet we installed, every wire we connected, every instrument we calibrated represented someone's son, husband, or father, depending on our workmanship for their survival. We were not simply manufacturing aircraft, we were building hope." The Willow Run facility itself became a monument to American industrial achievement, though its post-war fate reflected the challenge of converting wartime production to peacetime purposes. Ford declined to purchase the facility, recognizing that aircraft manufacturing required different skills and markets than automobile production. The plant's vast spaces would eventually house other industries, but none would match the drama of its wartime mission. Legacy assessments of Ford's bomber production emphasized achievements that transcended mere manufacturing statistics. Willow Run had demonstrated that free societies could organize complex industrial operations more efficiently than totalitarian regimes while maintaining individual liberties that gave meaning to the struggle. The facility's workers had built more than aircraft. They had constructed proof that democracy could win through organization, determination, and shared purpose. The final irony of German intelligence failures regarding American production capacity lay in their fundamental misunderstanding of democratic societies' organizational capabilities. Authoritarian observers expected that free societies would lack the discipline required for systematic industrial mobilization. Instead, American workers voluntarily accepted wartime sacrifices while achieving production levels that coerced labor could never match. Historical analysis of World War II's industrial dimension consistently identifies Ford's Willow Run achievement as strategically decisive for Allied victory. The facility's production of nearly 7,000 bombers, combined with similar achievements at other American factories, created the numerical superiority that overwhelmed Axis resistance. Military historians recognize that victory came not through superior tactics or individual heroism, but through industrial mathematics that favored the side capable of sustaining losses while maintaining offensive pressure. The story of German spies' shock at Ford's bomber production remains a testament to the power of underestimating democratic society's capabilities. Every 63 minutes, another B-24 had emerged from the Willow Run assembly line, carrying with it the promise that free peoples, properly organized, could outproduce and outlast any authoritarian challenge. The shock waves from that achievement continue to resonate through history, reminding future generations that industrial capacity, properly applied, remains democracy's ultimate weapon.